right, learning goal today, the student will understand y-intercept and how to use it to graph a line. This is another one of those major things that we're going to use forever now. Like once I teach you, it will come up so much next year. It will be nuts, okay? So first thing I want you guys to do is understand what the y-intercept is. I think I introduced this to you just kind of as I've been talking about graphs, but now I'm officially saying you have to know it. So the y-intercept is where your line crosses the y-axis, just like it's pointing out each time. So far, graphs that are proportional have all looked like this, right? They've all gone through 0, 0. But we have discussed lines that have been shifted up or shifted down. Okay, so this one has a y-intercept of 4. Okay, and the y-intercept in math, for some reason, some person has given it the letter B, stands for y-intercept. And so that is going to be 4. Okay, I don't know. All right, y-intercept here is -3, and this would be B equals -3. Now, where it crosses the x-intercept, it is called the x-intercept, but we're not going to be dealing with that anytime soon, so you don't have to worry about that yet. It's only where it crosses the y. All right, next slide. Okay, as we start to put all this together, okay, letter A is pretty simple. What is the y-intercept of this first graph? -2. It's right here. All right, -2. The y-intercept of the second graph, it is +2. Okay, now, this is where it gets a little tricky. You guys think about what I've taught you, because I've kind of pre-taught you some of this. What do you, look at letter C. Think about what I talked about when I said lines are proportional. Lines that are proportional have to go through where? 0. And then remember that test we had, where it's like, is that equation proportionate? And why did we say it wasn't? It didn't go through the origin, so where did we talk about it going through? -3. It had been moved down 3 because of the -3 at the end. So the y-intercept of this one is this -3. Okay? And some people say, well, it's a -3. Yes, it's both. You have to remember that when you're taking something away, that is what negatives represent. And I have taught you guys that you can always say same, change, change. That's a -3 sitting there, okay, or a -3. Okay, what would be the y-intercept then on B? 3, +3, because it's +3. Okay, that's what makes it not proportional, is that extra part that's been added. And that's how the graph shifts, is that extra part that's been added or subtracted. Here. Okay, what is this right here? That's a good question. What is this part?
That's the proportion. Like
that's the proportional relationship. What else have we called that?
Scooper.
Yeah.
Scooper. You're like, what?
That looks like Scoopy?
Yeah, yeah.
All right, what have we no, we have talked a whole bunch about that. You just did that in today's warm-up. What is that? No. Slope. Slope. That's your slope. That's your slope.
So it just
Not a scooper.
that means the line is going down.
That would mean the line's going down. Yes, Eric.
I was close.
Yeah, no, you were not.
She's just gonna tell us.
All right. Okay. Oh, I like your hair today, Jake. He's telling me that.
Everyone has said
I think it looks good. I think it looks good.
Yeah, that's what Eric.
Speaking from the guy who I have a feeling has a lot of hair products in his house. So, I bet.
Okay.
No?
Yeah, no.
No, not really.
Zane doesn't have a lot of hair products in your house?
I do.
Oh, yeah.
I do.
You're smooth, man. That's like,
All
that kid's weird.
All right. Okay. All right, so graph the equation. Okay, so here's where this is all coming together. Okay, graph the equation x + 3. What is the y-intercept of the graph of the equation? So let's start there. What is the y-intercept of this equation? 3, okay, because it says +3. So we're going to go ahead and put in the +3 here, +3, and then we're going to think about where would that be located on a graph?
+3.
+3 on the y-axis, right? So I'm going to start by putting a dot right there. Okay, what is the slope of this equation? You do know.
X.
Nope. It does go up. Good.
Line.
It is a line.
says anything times 1 is itself, so they didn't add 1.
Yeah, mathematicians don't write any more than they have to. So there's an imaginary 1 that's sitting there. There's one x there. There's a single x there.
Like, so if there's 2 x's there,
There'd be a 2x there. Yes. Okay. If there's 3x, there'd be a 3 there. There's 1 there. Okay, so that means that our slope is 1. Okay. Now think about what we've been talking about. Slope is fun. Remember?
rise or run.
Okay, what is the only thing, so I need to make this into a fraction so that I can use rise and run. What is the only thing I can do to that number to change it to a fraction that doesn't change the number?
3 over 1.
3 over 1 changes the number dramatically. The number is 1.
1 over 3.
1 over 3 would be a third. That
1
changes
over
the
1
number.
over 1. Or 3 over 3. 1 over 1. Same
1
thing.
over 1. Now, I agree with Catherine for once that 3 over 3 is the same thing as 1 over 1. So if you wanted to use 3 over 3, you could. It wouldn't change anything. Okay, so does everybody understand what I just did there? Okay, so now think about, we're going to do slope in reverse. Okay, so remember how we were always like doing the right triangle? And we were saying rise and run? So now we're going to do it in reverse. So where would the next point be on this graph?
1.
Okay, which direction does this line need to go?
Up.
Up. And how do we know that?
Because it's positive.
Because it's positive. Because it's positive. It's not a negative one, right? So we know it has to go this direction. Okay, and with that direction, we know we want it to rise 1, run 1. So we're literally going to rise 1 and run 1. So rise 1, run 1. Rise 1, run 1. That's really hard to say. Okay, and you just keep going. And then this is continuous data because you could put in any fraction or decimal that you wanted, and we just graphed it. We didn't have to make a table. We didn't have to come up with anything. In life, give me an example of something that would be this equation. Any situation. Has to be increasing by what? And it has to start where? Okay.
My grandma gives me $1 every day.
Okay. Your grandma gives you $1 every day. What about the 3?
Every 3 days.
Nope. The first part, Nora. Nope. Kate?
She gives you $1 every day, but you started off.
There you go. But you started off with 3. That was the only part.
Also 3
Yeah.
plus 4.
And so it would start here, and then it'd be increasing. This would be your days. This would be your money, and your money would slowly increase over 1 of 1. All right, let's keep going. All right, let's see if we can graph one that looks harder, but really not. All right, so can we pick out the y-intercept?
5.
What's the y-intercept?
5.
5. This is the y-intercept.
It's positive.
Okay.
So
And it's positive. Okay, what's your slope?
half. Negative 1/2.
So which direction is this line going to go?
Down.
It's going to go down, right? It's decreasing. Where do I put my first dot?
Wait.
At the 5. What
Why
count?
is it going down like plus 5?
Okay, who's going to explain?
Oh, because it starts
Sorry.
because the slope is going down negative.
Because the slope is negative 1/2. Okay, so we're going to start our graph at the y-intercept, which is 5. Okay, where do I draw my next point?
Between the 5 and the 6.
Okay, what is slope? What are we supposed to remember with slope? Rise over run. So slope is run. Rise over run. So what do I have to do? Up 1? Should it be technically probably down 1 and where?
Over 2.
Which direction?
Left.
Right, because this is a positive, right? That's a negative, that's positive. So really what I should do is go down 1 unit and over 2 units. Down 1 unit over 2 units. Down a unit over 2 units.
Whoa, wait.
I can't see mine very well. No, that looks right. Down 1 over 2. Okay. Do I have one right here? It's when I'm up close, I can't see the lines.
It doesn't look right.
I have a question.
No, it's not.
I can't. Like I said, it's very hard for me to see these lines. So if I'm starting at 5, here's my 5. And then if I go down 1, yeah, this would be the next one. I'm good. Down 1 over 2, this would be the next one. There it is. Okay. That's where I should be, right there.
That's better.
All right. Okay, now, here's the flip side of that, okay? You could also call this 1 over negative 2. What would that make you do?
Same thing.
Okay, but tell me, that'd be the opposite. So where would I go here?
Down.
Left.
Up one.
Up 1 and
Over. Down. That way.
left. So I could go up 1 and over to this way. Did I get to the same spot?
Yeah.
Yes, and that's why we've always said you can have a negative in the numerator, denominator. You just can't have it in both. Explain to me why I can't have it in both on this one. Okay, what would it do to my graph?
Make it positive.
It'd make your graph positive, because let's think about that. If you had a negative 1 and you went left 1, where would you end up? Over here, right? And then what happens to your line? Did you guys see that? You can't go down and left. See how if you go down and left, you've now turned it positive? That's why that double negative can't work, because it's going to turn to a positive. Okay? All right. Where what? You can have it on one or the other. You just can't have it on both. All right. I think you guys are ready to try one on your own, so go ahead and try this one.
Wait, so if
Yes,
there's,
you are.
if there's two negatives, is
All right, what is the y-intercept? Eric.
negative plus?
Nope.
Negative 1.
-1 is the y-intercept, okay? So that's where I have to start. So everyone should have their first point on -1, okay? What is the slope of this line? Yeah. Okay, and now let's turn it into a fraction.
5 over 1.
-5/1. And I'm going to remember that slope is fun. This is my rise. This is my run. Okay? All right. So from this point I've drawn, I have to go where?
Down.
Down. How many?
5.
5. And then over 1. And which way do I go? Left or right?
Right.
Go to the right because it's a positive. So I'm going down 1, 2, 3, 4, 5 over 1. There's my next line, or my next dot that I showed on there. Make sense? Okay. If you think about that, let's say that you're losing $5 every day. You're losing pretty quick, right? That's why that line is so steep, because that's a lot of loss. Or you're losing $5 an hour, or you're losing 5 degrees an hour, or whatever it is. Okay? And then I could also go the other direction, right? I could do a +5 over a -1. Okay? So I could go, how would I do that one then? Up 5, and then over to the left. Okay? So 1, 2, 3, 4, 5 would be here, and to the left 1, I think, would be close to that. And there's your line. Okay, questions on that? Does that make more sense? Yeah, this is a huge thing. Trust me, this might feel hard today. You will get to a point where this will be so easy, it'll be like adding. Like, yeah, I can graph this stuff all day long. Trust me. The more you do it, the easier it gets. All right. The last one, the line models the total amount of snow on the ground during a snowstorm. What is the y-intercept of this line? Justine. 3. All right, what does the y-intercept represent in this situation? Yana. Very good. How many inches of snow were already on the ground? Next question, what is the slope of this line? Eric. 1/2. So I can look between any 2 points I want. The rise is 2. Sorry, the rise is 1. The run is 2. This line is going up. It's increasing. So the slope is 1/2. And what does the slope represent in this situation? Jeremiah. Half an inch an hour? What do you guys think? Yeah, half an inch an hour. If I had to write an equation for this graph, what would the equation be for this graph? Everybody think about it for